So the way these work, I think everyone's first time, we pick a theme for each session, and then we do an hour on that particular theme. A lot of the problems are drawn from this book, which can be a helpful resource as you study because it has tons and tons and tons of practice problems, and they are divided up by topic. So if you want to work on rates, there's a whole chapter on rates problems. And I really hope you want to work on rates because that's what we're going to talk about tonight. We're going to start just really from the ground up with very simple facts about problems that involve rates. And then we're going to build up into some pretty complicated GRE problems. But my hope is that we will start with the foundations and go gradually enough that by the time we get to the tough stuff, it maybe doesn't seem so intimidating. And all of the problems that we do tonight are going to be sort of regular math problems, either 5-answer multiple choice or text entry. You'll see both of those on the GRE. So they should look, I think, at least in format, kind of similar to math that you have maybe done before on the SAT or ACT or in school, even if that was a long time ago for you, like it is for me. So we'll talk about rates basics, and then we'll get into some GRE-like problems. And I apologize, I have a little bit of a cold. It hopefully won't impact today, but I can hear my voice is a little funky. So I'm sorry about that. At any point too, please, especially because we have a small group, like throw some questions in the chat. Stop me if you don't understand something. You know, we have a nice 6 of us here tonight, so we can take time to make sure everyone feels super comfortable with everything before we move on. So let's talk about what rates are. I really like rate problems because unlike some of the other math you're going to see on the test, like for example, geometry, there's not a lot to memorize. And we're going to learn, I think, 3 formulas tonight, and 2 of them are basically the same thing. So when I talk about rates or rate problems, I'm talking about situations that essentially ask this, like, how far am I traveling? How many things am I making? And we're going to want to know how far we travel in each unit of time, so like in each minute or each hour, how many minutes, hours, etc. we're traveling, and that's going to allow us to calculate our total distance. And that's one of our first 2 equations. Rate times time equals distance. Probably familiar, simple, can be applied in complex ways, but our foundational idea here is just this one equation. We might also get situations that aren't about distance, but are about making things, like producing gallons of paint or a number of robots. And in those situations, very, very similar equation. We're still thinking about rate, how many things we make in each unit of time. We're still thinking about how many units of time we're working. And for this equation, you'll see rate times time equals work. So same idea, just written a little differently. One thing that I also like about rate problems is that they happen in the real world. So I can use the units to help track my work and make sure I'm setting things up correctly. So for something like this, just a really simple example starting out, I would often write it down like this. I'm going 60 miles in every hour times 3 hours. That's my rate times time. And then what I see is, oh, I can actually cancel out my units, just like I cancel out anything in an equation. I could say, okay, I have an hours in the denominator. I have an hours up here. They cancel out. So I have 60 times 30 is 180, and that gives me 180 miles. So I like to sometimes do this kind of writing out the units as well, because then I know I've set it up correctly when I get the right units at the end. It'll get more and more important as things get increasingly complicated. This can also help. We're going to see some kind of long word problems today, and it can also help us just figure out what information we have. So like, is it a rate? Is it a time? Is it an amount of work? Rate units are really easy to spot. You know a problem is giving you a rate when you see this word, something per something else. Time units, super obvious, all different kinds of time that we might see. And then distance or work, obviously things like miles, feet, and yards. But when it comes to work, it can be just any fixed quantity that we're producing, like gallons or number of cups or number of tanks. We're going to see a problem with tanks tonight. so I can track that in that way. And sometimes these problems get hard because it does just get tricky figuring out and sorting through all the information that we're given. But again, you can use units to help. All right, so now I have a question for you. I don't want you to solve this problem, but I do want you to tell me what really important things should I take note of before I actually start doing my calculation here. If I were gonna solve this little question. Just reading it over, anything that's like, oh, that's weird. Yeah, nice job. I have different units. My rate is given in hours, but I'm asked for minutes. This is just one of those little twists that the GRE will give you where you can do all of your math beautifully and then maybe end up inputting the wrong answer because you missed these little twists. So especially with rate problems, watch out for situations like this where we have to convert. And for me, my rule of thumb is always, if I see that a conversion is needed, I'm gonna convert first. That way I know it's done, I don't have to worry about it, I'm not gonna forget about it later on and make a mistake. So how do I convert? If I have 60 miles per hour, how do I change that into miles per minute? You're on the right track, Jen, for sure. But it's not going to be multiplying. Like if I multiply this by 60, I'd get, and does that make sense? No, like we're not going to be going more miles in a minute than we would in an hour. So always with word problems, common sense is super helpful. Yeah, yep. That's it. It's going to be the inverse of that. And I think about this, I don't like converting units. This is not a natural strength for me. My high school physics teachers can attest to that. But I think about it the same way I think about that canceling units I showed you. I'd say, okay, I know that in 1 hour, there's 60 minutes. So I set it up that way. And then I can say, okay, 60 miles per hour. Well, then in 1 hour, I have 60 minutes. Like that. And I see, okay, my hours cancel out. So I have 60 miles divided by 60 minutes. That's going to give me 1 mile per minute. And now that I've converted my rate, I can go ahead and set up my rate equation. I'd say rate times time equals distance. I have my rate, 1 mile per minute. I don't know my time, so I'm going to put a variable t. And then I know I'm going 180 miles. I can divide, oh, this is actually really easy. I can divide both sides by 1 to cancel out that rate, but that's just going to give me 180 minutes. So that one, I think you could probably just reason out in your head because I chose nice, clean, simple numbers, but just to show you how I would set that up as before we get into trickier things where this setup gets pretty important. Everyone all good so far? Any questions or concerns? And if you're like, no, this is super simple, I got it, don't worry, it's gonna get harder. All right, so you're gonna do a little exercise. Here are 3 questions. I'm gonna give you a couple minutes to work on them. I'll show you them in a second. What I'd like you to do when you've done all 3, go ahead and share your answers with me, but just share them with me. So you'll see in the to field on the chat, you can change the to all panelists. Change it to all panelists, and then I'll be the only one who sees your response, so you can chat me your answers, but not influence your classmates. Here you go. Try these 3. And if you get stuck with something, chat me and let me know that, and I'll give you a hint. All right. I have some nice answers from a couple folks. If you haven't chatted me yet, at least chat me what you have so far. I know what you're thinking before we walk through these. And if there's one you're feeling stuck on, yeah, it's looking good. All of the answers I have seen so far are correct. So I'm feeling good about this. We're going to do some fun stuff. All right, so first one, how long? I immediately know I'm looking for time. 50 miles per hour, that's my rate. I have a distance, so I can say 50 miles per hour times whatever my time is equals 200. Divide both sides by 50, and I get 4 hours. Nice. Second one, all right, so now I have a time and a quantity. So I'm going to start by finding my rate. My rate equals my work over my time. So my rate equals 120 over 3 equals 40. So I pick 40 apples in an hour, and then times 4 hours. Give me 160 apples. And then this last one is a little bit of a variation on what we've seen so far, and it connects to what we're going to talk about next, which is multiple people working together. For this one, you can think of the work equation like a variant of the work equation. The number of people times the rate per person times time equals work. So for this one, I'd say, okay, 1 person, 4 hours, 8 necklaces. I have my work and my time, so I know rate times 4 equals my work. So my rate is 2 necklaces per hour per person. So then I can say, all right, 6 people times 2 necklaces per hour per person times 2 hours is going to give me 24 necklaces. Great. All right, one more twist to look at, then we're going to do some problems. So take a look at this. This is a super, super simple question. Amy can make 2 cookies in a minute. Rohan can make 3 cookies in a minute. If they work together, how many cookies can they make in a minute? Really straightforward. Can do it in an instant. Like 2 cookies a minute plus 3 cookies a minute. Well, obviously, they're going to make 5 cookies in a minute. And that makes sense. They're going to make more cookies working together than they would working alone. But what if I then have something like this? Take a look at this. And then my question for you is, what do I need to do first? What's the first thing that I would need to calculate here or to find out here in order to begin solving this problem? Yeah, awesome. I need to basically get this problem to the place that first simple problem is at, where I have the same unit for both of them, 1 hour. Essentially, I need to find the rate. Now, as soon as I get into any rate problem that's more complicated, my kind of #1 tip, I think, for dealing with these rate problems is to set up a chart. Keep your work super organized. This is a great general GRE principle. The more you write down your work, the more organized it is, the more efficient, more accurate, less tired you're going to be. I promise. It'll maybe feel like it's slow if you're starting out and you tend to like to do things in your head, but push yourself to write down more. It's really going to help. So for something like this, I'd set up a table, and I'm going to show you because I think you might find it helpful as we get into some problems today. So I have Amy and I have Rohan, and I have Amy and Rohan together. And I have how much they make. Amy makes 60 cookies, Rohan makes 80. I have their time, 3 hours and 2 hours. And so now I can find the rates. 60 divided by 3 is 20. So 20 cookies in an hour. 80 divided by 2, 40 cookies in an hour. And then I'm like, cool, 20 cookies in an hour, 40 cookies in an hour. Their combined rate is those two things added together. 60 cookies in an hour times the 1 hour gives me 60 cookies. Works for something like this. This same chart is going to work as things get increasingly tricky, increasingly complicated. All right. Any questions? Because now I'm going to turn you loose on a couple of problems. Try applying all this stuff in a more GRE-like context. All right, here you go. I'll give you 2 minutes or so to work on it. If you get an answer, chat it to me. If you need a hint or get stuck, chat me too, and I'll help you out. Hey guys, so it looks like a couple of folks are a little confused, so let's do it together. Yeah, I told you it was gonna get harder. It's gonna get sneaky. So I'm gonna start this the way I'd start it, and then I'm gonna call on all of you to kind of help me along with the steps. So I'd start this by making a chart, because I love charts for rate problems, and pretty much as soon as I see it, a rate problem, I make a chart. And I'm making 3 rows because I know I have Sabrina by herself, Janice by herself, and then Sabrina and Janice together, and 3 columns for rate, time, and work. All right. So now, and this is a good thing that I do for like any word problem where there's just a chunk of text, I just go through and I process it little piece by little piece. I take my time sifting through the information so that I don't get overloaded and overwhelmed and panic, because math does make me panic sometimes, a little bit. So starting at the beginning, if Sabrina can assemble a tank in 5 hours, all right, let's just deal with that. So in the Sabrina row here, what can I fill in? Like, do I have a rate? Do I have a time? Do I have an amount of work? Tell me in the chat. Yeah, I have hours, so I have time. Anything else? Do I know how fast she's going? Do I know how much she's making? Yeah, and I know the work. Nice. Luz chatted 1 tank. Cool. So I can put a 1 here, 1 tank. And then I can do the same thing for Janice. Janice can assemble 1 tank, so that's my work. And it takes her 10 hours. Awesome. Now I want to know Sabrina and Janice working together at their rates can assemble a tank in approximately how many hours? So what am I solving for? What is the ultimate thing that I'm finding? Rate, time, or distance? Liz said rate. Is that like the answer? Like when I pick one of these answer choices, that a rate? Maybe you got confused because I'm going to need to find rate in a moment for sure. Yeah, my ultimate goal is time. How many hours? So I'm going to put my variable there, T. And then I know, again, they're assembling a tank. So I know how much work they're doing. I can put 1 tank. Liz, maybe this is where you were going. Now it's really obvious what I have to do next. I think just based on the setup of the chart, I have this big empty column for rates. So I need to start filling in my rates. So what is Sabrina's rate? 5 hours for 1 tank. Yeah, Jeff says 1/5. So I have 1/5, right? Because I have rate times time equals work. So I divide work by time and I get my rate. And same thing here, 1/10. And now working together, thinking back to our previous example, I just add those rates together. So 1/5, let's convert that to tenths. So that's 2/10 plus 1/10, 3/10 is their rate. Now I just have to set up my equation. I have 3/10, my rate, times t time equals 1. To get rid of this, multiply by 10/3. So I cancel this out. And I get my time equals 10/3, which is about 3 1/3. So not exactly one of my answer choices, but this problem has this nice language approximately. So I'm like, okay, that's closest to 3. And that is my answer. Now, let's say you got this problem. You had to take the official test tomorrow. You got this problem. You're like, oh, I still don't like rates. It's super tricky. I'm going to guess on this one. If you were going to guess, which is a good thing to do on the GRE, which answers could you at least rule out without having to do any math? Yeah, Luz said I could rule out 5. Because if Sabrina can do a tank in 5 hours just by herself, once I add in Janice, it's going to get faster. And I could also rule out 6 for that reason. So even if you occasionally have to guess, see if you can at least cut out a couple answers. What tripped people up here? Or do you still have questions about anything that I just did? Where was this? Because a couple of folks are like, I'm not quite sure what to do. What was that moment where you felt a little like, oh, I'm not sure? What's tricky here? Yeah, not a lot of love for the fractions. And that'll just come with practice if you're just starting out. You know, you'll do some drills with them, you'll get more comfortable. You certainly, because you have a calculator, could use decimals as well. If you prefer that, put them in as decimals. If you really hate fractions, that's okay to do too, especially because we don't get a nice clean answer here. Yeah. Yeah. And a couple of folks are saying it was the like figuring out the rate was tricky. Do you feel clear on it now? Or because we're going to do another problem that's kind of similar to this one. So I want to make sure folks are feeling like, okay, I'm getting there with how to figure out this rate business. Like one way I'd look at this problem is I know as soon as I read it, I don't have any rates given. I have no this per that word isn't there. So that's sort of my big clue starting out. All right, I'm going to have to figure out the rate at some point. That's going to be a big component of this. All right, let's try another one. This one is similar, but it has a little extra twist to it. But you can still use, you can use kind of the same chart, very similar process to do this. Try it out. If you're getting stuck, chat me. I'll help you out. All right. Everyone, let me know where you're at. You know, chat me an update. Are you getting there? I'm seeing some nice answers coming in. Or are you stuck somewhere? If you're still working productively, keep working. No worries. I know a lot of you are just starting out. It's the first time you're seeing a problem like this. So it takes time. Speed comes just with practice. Definitely does not come just starting out. Cool. Let's start setting it up together. No, Adani, you were right. You had the right answer. I think you're second guessing yourself, but I'm going to stop you. All right. So I have Anya, David, Anya, and David. Rate times time. Oh. I was already jumping ahead to the next part of the problem. Equals work. Cool. So let's do the same thing we did with last problem. What can I fill in Anya's row? Just from that first sentence. Nice. Yeah, I can put in time. And what else? Yeah, I've got work. I've got an amount. And this is the sneaky thing. This is how the GRE likes to add difficulty. Instead of a number, they give me a variable. Ugh. But I'll put it down. I can put the same thing down for David. Why? And then I want to know how long it will take them. So I'm looking for time again. And they're going to make 3Y liters of paint. So at this point, I'm like, okay, I could start solving for rates. And I'm getting some really gross fractions. I'm going to have to deal with algebra and fractions. I know there's not a lot of love for fractions in this room, but we don't actually have to do that. There is a way that we can make the calculation part of this problem much nicer. I have the same variable y used throughout. Does it actually matter how many liters they're making? If they're making 10 liters or 13 liters or 17 liters, is that going to change my answer? Thoughts? Well, I'm making y here, and I'm making y here, and I'm making 3 times that amount. So it matters that they're making the same amount and then 3 times that amount. But it doesn't matter what that amount is. It just matters that it's consistent. That's sort of what the variable is telling us. Like, same amount of work here, 3 times this amount of work here. So if I really don't want to work with a variable, and I don't because I think it's going to slow me down, I could replace that variable with a number. And I could pick any number that I wanted to that was going to be easy to work with. So I'll let you guys pick what's going to be a number that I could plug in for y. Maybe looking at our rates over here, that's going to be really easy. 1 is often an easy number, but will it allow us to avoid fractions? What's a number we could pick where I won't have to deal with fractions because you guys don't like fractions? Everyone likes 5. If I divide 5 by 10 and 5 by 15, though, I'm still going to get fractions. Go bigger. Think about dividing by 10, dividing by 15. Yeah. Yep, let's try 30. I said you guys could pick whatever you want, but then I bullied you into picking my number. But it's because I want to show you how easy we can make this math if we just take a moment to think about picking a good number, a good strategy. Yeah, a few folks arrived at 30. Then it's 3 times that here, so I'll put 90 here. So now for my rate, 30 divided by 10 is 3. 30 divided by 15 is 2. And then it's really easy to find the combined rate. Instead of having to add these gross fractions, I just add 3 and 2, and I get the rate is 5. And I can set up another nice clean equation, 5t equals 90, t equals 18. 18 minutes. A couple folks arrived at. It's very nice. So that's a cool trick. It makes life a little easier. Maybe if you did the algebra this time, this is a good thing to take away from this problem. Like, okay, cool. I know how to do this. Like this longhand way, I clearly get rates, but here's a little trick I can be alert to that'll save me some time. I can do it faster. And you can pick numbers, assign a number, anytime actual value doesn't matter. So that could be a problem that's all fractions or all percents or all like a constant variable, like what we saw here. And this strategy is going to work, and it'll just save you energy, save you time. Even if you love algebra and you're super great with it, still can be a lot easier to pick a value. And if that was what was hanging folks up, if you were like, cool, I set up the chart and then I'm kind of stumbling over these weird fractions, this I think can really help with that too. If the thing that's bothering you is the variable, get rid of it. Make it easier for yourself. All right. Everyone chat me. We're going to do one more rate problem. It's going to be similar, but it's going to add a little twist. What's something that you want to keep in mind on the next problem that you think is going to help? What's the takeaway you have about rates from the work we've done so far? Everyone chat me something. When I see a rate problem, I'm going to do what? Ooh, track units. That's a good one. That's a popular one. And I'm not making you do this just to entertain me. I'm making you do this because this is a super important thing to do when you study, especially folks starting out. Maybe the biggest thing I have to tell you today is every time you do a problem or a couple of problems, find a lesson in those problems that you can apply to other problems. That way, you learn how to do the problem. You're not going to see that problem again, but you also learn something that you're going to be able to use as a tool to solve all kinds of other problems like that in the future. All right, here is one more. It's gonna get kind of tricky. So take your time. There's a lot of text on this one, so be patient with yourself. Just take your time to really process each sentence, understand what's happening. If you go slow on that stage and on the setup, then the actual work will be efficient. So be patient with yourselves. Here you go. All right, let's talk about it. This one is tricky. So here I'm going to set up our chart. Always, always, always with the chart. It's good to have like a really consistent plan for different problem types. Like I see rates, I make a chart. I see percentages, I pick a number, things like that. So then you don't have to stress about sort of that unknown on the test. So I have rate times time equals distance. And I have car A and I have car B. And I have a nice rate for car A, it's 40 miles per hour. And I have a nice rate for car B, it's 30 miles per hour. And so far so good, but now I'm stuck because I only have that. And if I only have time, I can't find distance, I can't find rate. There has to be something else going on here. At some point, if you look at a problem and you think, oh, it's only given me one of these three pieces, take a second look, because there's probably going to be a sneaky way that they've given you one of those missing pieces. So where in the problem do I get the information that's going to allow me to fill in another column here? And I put those under time instead of under rate. That was silly. But what's the other piece of information I'm going to need to use? Nice, yeah, yep. I know that each car started with 8 gallons of fuel and it can go 30 miles per gallon. And that's going to tell me about the max distance that either car could travel because they can only use their fuel. So 8 gallons of fuel times 30 miles per gallon gives me 240 miles. Which car is going 240 miles? Got one vote for car B. Both. Got a vote for both. Why? How do I know? What in the problem tells me it was B or it was both? Because the problem is actually tells us very clearly. We know it can't be both because if both ran out of fuel, both would travel 240 miles. And it asks us how many miles apart. None of our answers are 0. So it can't be both. Yeah, they both consume the same amount of fuel at the same rate, but it tells us car A ran out of fuel. Nice. So car A is going to go 240 miles. And now I know how long car A spent. Car A went for 6 hours. How long does car B spend? Car A spent 6 hours. How long does car B spend? Here's your hint. How many hours is car B spending? If car A is spending 6 hours. So it says 1 hour, it says 1 hour later. So is car B spending less time or more time? Maybe the wording isn't clear here. 1 hour later is in like 1 hour after car A starts. So car A starts, and then an hour after car A starts, car B starts. Does that help? Like you could think about it, maybe I start work at 8 and I work to 5. But if someone starts an hour later me, they start at 9 and they work to 5, they're gonna work less time. Yeah, so if car B starts an hour later, 5 hours. Yep. And I think that might have been the twist that tripped a few of you up. It's one of the really sneaky little parts of this problem. Now I can find car B goes 150 miles. But my answer is not 150 because they're asking me how many miles apart. So I do 240 minus 150, and I get 90. Super, super tricky question. Lots of twists and turns in it. If the phrasing, things like 1 hour later, trip you up in word problems, or if you find word problems tricky, make like a dictionary for yourself or make little flashcards with those phrases and their translations. That's a great way to just get super comfortable with the way the test uses language in these types of problems. Another thing you might want to do, this is a really tricky problem. There's a lot to learn from it. I'm going to put up a clean version of it for a moment. Maybe just take a screenshot of it and try it again in a week or 2 weeks or further down in your studies. See if you can come back to it, and maybe next time it starts to feel more comfortable as you get deeper into this. The correct answer is C, if you do want to come back and try the problem again. All right. We did not get to the other thing I wanted to do, which was average speed, but maybe I'll do that in a later session. For now, we're at the end of our hour. Thank you so much for coming. It was great to have you all here. I know it was small, so you all had to participate a lot, which is maybe not what you were expecting, but hopefully you got something out of it. You can also always sit in on the first session of our full course for free. So that'll cover all of the, like, you know, what is to expect on the GRE, core math, core verbal, all of that stuff as well. We also post these free prep hours on our YouTube channel. So there's lots of different topics from past ones. If you're like, I want to do something with geometry, there's one on that. You can check out too. And thank you all for being here late at night or early in the morning, wherever you are. Good luck with your